Hi everyone and welcome to Smart Culture Education. This is the place where we make learning simple, clear and engaging. If you're new here, don't forget to subscribe so you can join us on this journey of mastering maths, science and more. Moving on to a geometric sequence. A geometric sequence is characterized by each term being the result of multiplying the previous term by a constant ratio, known as the common ratio. This pattern of multiplication makes geometric sequences especially interesting and useful in both theoretical mathematics and real-world applications. So in this case, the nth term is determined by the formula a times r to the power of n minus 1, where a is the first term of the sequence, r is the constant ratio, which you can find by dividing any term by its preceding term, and n is the position of the term in the sequence. Now, the sum of the first n terms can be calculated using the following formula. A multiplied by r to the power of n minus 1 over r minus 1, or a multiplied by 1 minus r to the power of n divided by 1 minus r. And in this case, r must be less than 1. If the absolute value of r is less than 1, then this series will converge and the sum of all terms can be expressed as a over 1 minus r. Let's take a look at question 2.2 from the 2019 past paper. So the average score for this question was 57%. Let's take a look at the question. Given the geometric series 5 over 8 plus 5 over 16 plus 5 over 32, and so it goes on, equals k. Determine the value of k if the series has 21 terms, and determine the largest value of n for which Tn is greater than 5 over 8,192. Let's take a look at the given information. So you will see that the first term a is equal to 5 over 8. Now, what do you think is the common ratio r? Let's compare term 1 and term 2, and then term 2 and term 3. Each time we multiply by 1 over 2 to get the next term. So that means r, the common ratio, equals 1 over 2. Another piece of information that is given to us is the value of n. They tell us that n is equal to 21. So now we have the value for a, we have the value for r, and we have the value for n. So what we'll do next is we'll write down the formula for the sum of the first n terms of a geometric series. So it will be equal to a multiplied by 1 minus r to the power of n divided by 1 minus the common ratio r. Now we have the value for a, we have the value for r, and we have the value for n, so we can substitute these values into the formula. So then we get 5 over 8 multiplied by 1 minus a half to the power of 21 divided by 1 minus a half. Now, what is 1 minus a half? 1 minus a half equals 1 over 2. It's still a half. So we can simplify that. Now, we can also get rid of the exponent. So instead of writing a half to the power of 21, we write 1 over 2 to the power of 21. Here we've applied the power of a quotient rule. Now, the next thing that we'll do is we'll punch this into our calculators, and then you will see the answer equals 1,24999, and so it goes on. So we can round the answer to 2 decimal places, and then it will be 1,25. Next, we will take a look at question 2.2.2. Determine the largest value of n for which Tn is greater than 5 over 8,192. Let's take a look at the given information. Tn is given to us. It is 5 over 8,192. What we'll do next is we'll write down the formula for the nth term of a geometric sequence. Tn equals ar to the power of n minus 1. Now remember, we have the value for a, we have the value for r. So what we'll do now is we'll substitute the given values. So now we have a times r to the power of n minus 1 is less than 5 over 8,192. Now a is equal to 5 over 8 and r is equal to 1 over 2. So let's substitute these values. So now we have 5 over 8 multiplied by 1 over 2 to the power of n minus 1 is greater than 5 over 8,192. what happens next? Next, we take the 5 over 8 to the other side and we divide it, and then it becomes 1 over 1024. Now we want to solve for n. So what we'll do is we'll rewrite 1 over 1024 as a half to the power of 10. What we want to do is we want to work with the same bases so that we can cancel them out. So now we have 1 over 2 to the power of n minus 1 is greater than 1 over 2 to the power of 10. So we cancel out the bases, we equate the exponents, so now we have n minus 1 is less than 10. Now, why did we change the sign? The sign changes in the inequality because of the properties of exponents and the nature of the base of the exponent, which in this case is a fraction less than 1. So, since 1 over 2 is less than 1, the function 1 over 2 to the power of n minus 1 gets smaller as n increases. Therefore, for the left side of the inequality to be greater than the right side, the exponent on the left side must be smaller than the exponent on the right side. So when you reverse the inequality, you acknowledge that a smaller exponent results in a larger value for bases between 0 and 1. Thus, n minus 1 is less than 10 in this case. So now we have n minus 1 is less than 10. Now we want to solve for n. So we take the negative 1 over to the other side. It becomes positive 1. 10 plus 1 equals 11. So that gives us n is less than 11. And this tells us that n must be any value less than 11 to satisfy the original inequality. The largest integer less than 11 is 10. Hence, we can say that n equals 10. So the sign changes from greater than to less than because the base of the exponent 1 over 2 is less than 1, making the exponential function decrease as the exponent increases. This inverse relationship between the size of the exponent and the value of the function is why the inequality sign flips. Thank you for watching today's video on Smart Culture Education. If you found it helpful, don't forget to hit the like button and subscribe to the channel. And if you want to stay updated, tap the notification bell so you never miss our next lesson. See you in the next video.